Hello, good morning, good afternoon, and good evening to you. Based on the period of time you are following and also watching our video, I am Ismat. Today, I will be introducing the classification of physical quantities. Remember, in our previous video, I touched so many things, the measuring tools, and the other things as well. So in today's class, I will be classifying physical quantities based on two different things or two different quantities, which are fundamental quantities and the derived quantities. We all know what fundamental quantities is, right? Or are. Okay, fundamental quantities are quantities that cannot be expressed in terms of other quantities, or they are quantities which other quantities depends on. They are quantities which other quantities depend on. So that is what fundamental quantities are. Now it is very clear, right? When we talk about fundamental quantities, talk about the length. Examples are the length, the mass, time, temperature, electric current, luminous intensity, and the amount of substance. Now the SI unit of length is meter. I've explained it in our previous video, which is m. Kilogram, which is for mass, kg. Seconds, Kelvin, ampere, candela, and mole. Now that is for what? That is for what? Fundamental quantities. Now, for derived quantities, talk about their quantities obtained by combining fundamental quantities using mathematical relations. Are you there? So these are the quantities that we are talking about. They are being derived. They are being what? Derived from what? The fundamental quantities. Now, the quantities like area. Area, when you multiply length by breadth, you get what? Area. And the SI unit of area is m squared. When you multiply length, breadth, and the height, it will give you what? Volume. And the SI unit is what? M cube, meter cube. That is the SI unit. The unit of volume is what? Meter cube. The same thing applicable with speed. Distance over time. Speed is what? Distance over time. The unit of speed is meter per second. Meter per second. Unit and velocity has the same unit. Speed and velocity has the same unit. Now, for velocity is displacement over time, but the unit is meter, but the unit is also the same unit for speed. The unit of velocity is the same unit for speed. We talk about acceleration. Acceleration is change in velocity over time. Change in velocity over time. So when we mean change in velocity over time, you can just say initial or final minus initial all over what? Time. That is acceleration. And the unit, please don't forget this unit. These units here, they are important. This one is m squared, m cube, m per second, and m per second squared. That is for acceleration. Please take note of this unit because we are going to use it during our dimension and dimensional analysis. Then force is mass times acceleration. Mass times acceleration, ma. And the unit of force is what? Newton. N is what? Newton. That is that for this derived quantities. So another thing I can also tell you is density, mass over volume, which is kg per meter cube. Remember, from volume, remember that volume is m cube, right? Let me show you. Volume is m cube, right? This is volume. So when you say that density is mass over volume, that is this thing there will give you kg per meter cube. That is the unit. Mass is kg, right? Or mass, the unit of mass is kg and the unit of volume is meter cube. Don't forget. Then we look at pressure. Pressure is force times area. The unit for pressure is Pascal. That will be all now for this one. Then we talk about speed. Speed depends on time. That is, it is what? dq, derived quantity. Mass does not depend on any other. That is, it is what? Fundamental quantity. So I've already explained measuring instruments and the meter rule and all the rest. So now I'll be explaining what we called dimensions and the dimensional formula and its analysis. Please pay a very close attention. This thing, you must see it in your exam, in your JAMB exam, or any exam that you are taking in physics, so far in secondary school or any exam, you must see it. Dimension. The dimension of a quantity shows how it depends on fundamental quantities. I explained. Fundamental dimensions include the fundamental dimensions we know include length, mass, and time. Length does not have any derivative. Length, the unit of length is L. The reason I'm writing this L very, very well, so that it will be clear. It will be clear to you. And the mass is what? M. And time is what? T. Are you saying it? So, for dimensional formula, a dimensional formula expresses a fundamental what? Quantity in terms of M, L, and what? S. And T. Are you getting me now? Now we talk about dimensional formula of common quantities. Now we move. Please pay attention. The dimensional formula for fundamental for some common quantities are: for velocity. Velocity is distance over time, right? Now distance, in fact, let me just go straight to where I worked something. This is where I worked it. Let me come. Now, these are our workings. Please pay attention. Workings for dimensional formulas. Are you there? So for velocity, it is what? Distance over time, which is distance. We all know that distance is length, right? Which is L. Time, it is T. Remember your indices. Your maths teacher will also tell you, when this is coming up, there will be a minus. That is the reason we are having LT minus 1 raised to power minus 1. So this is the dimension of velocity. I repeat, this is the dimension of velocity. Remember your indices. When something that is in the denominator is coming up, it will do what? There will be, your indices will tell you that it will carry a minus sign up. That is raised to power minus 1. Are you getting me now? For acceleration, remember I told you that acceleration, the dimension for acceleration is velocity. Remember that acceleration is velocity over time, right? Good. Now acceleration for velocity, you already have, let me work it out for you. Let me bring out something. This is acceleration, A equal to V over T, right? Good. Now V is what? Velocity, right? And velocity, we say that velocity is LT minus 1, right? Good. Then let us just put this one all over T, right? Good. Now when this is coming to this, it will be what? LT minus 2. Are you seeing it now? Are you seeing it now? So this is the dimension for what? Acceleration. Let us go into force. Force is mass times acceleration. Mass is m, right? Mass is m. Then acceleration, we have already gotten acceleration, so you have to put it this way: LT minus 2. That is for what? Force. Are you there? For momentum, momentum is the product of mass and velocity. Mass and velocity. So you bring out your mass m, velocity is LT minus 1. This is for momentum. Are you getting me now? So this is how to get the dimension of anything. Work is the same thing as energy, and energy is force times distance. You bring out your force. This is, let me bring out force. This is force equal to, when you bring out force, force is what? MLT minus what? 2. Are you there? So we say that momentum is the product of mass. Momentum is the product of, work is the product of force and the distance, right? So this is for force. Then distance is L. Let us just put multiplication sign here, L. So when this is coming here, it will be what? ML. This L will be what? Multiply, which is what? Squared. T minus 2. This is the dimension for what? Energy. The same thing applicable with work. The dimension of work is the same thing as the dimension of what? Energy. Then please, your assignment is find the dimension for power. Power work over time. Power is work over time, right? Pressure is force over area. Density is mass over volume. So you find that one for me. Now, another topic we want to look into is what we call dimensional analysis. Now, dimensional analysis is the method of using dimension to check one equation, to derive formulas, and convert units. So with the help of dimensional analysis, you'll be able to check whether the equations are correct, the exactness of equations, derive formulas, and convert units. Please pay attention. Now let us check physical equations. Example 1. This is S equals to UT plus half AT squared. Let us check whether this thing is correct. This equation is correct. Alright, these two equations, we see that X equal to UT plus half AT squared. This is equation of motion. When we come over here, we are going to as well list out the equations of motion. But for now, we are just dealing with the dimension and dimensional analysis. Now, for this, we can, to check whether this equation is correct, we start with X. Remember that S is what? Length, right? S is length, that's distance. Good. Then we also say that this is the, okay, let me just use this. S is length, right? Good. Then UT U, remember that U is our velocity, right? And velocity is what? L t minus 1, right? Good. Then time is also, this is time, t, right? Good. So when you cancel this out, this is t minus t is what? 1. So that means this ut remains what? L. That is ut is still what? L. Is still what? L, sorry. So for half, please, whenever you see half in dimension, don't look at any number. Dimension does not look at constant. It doesn't look at all those things. I will still list them out for you. So this half is gone. Then we look at a t squared. A is what? Acceleration, right? Acceleration, which is a. And acceleration is what? L t minus 2, right? Good. Now t squared, which is also what? T squared. There, right? This t here. So now when this t minus t cancel this out, it will remain what? L. The same L that we are talking about. So therefore this x is L equal to L equal to L plus L. So everything is what? L. So that means this equation is what? Correct. Limitations of dimensional analysis. 1. These are the things that dimension does not do. It cannot determine the dimension of a constant like half, 2, pi. All these things, it does not determine the dimension. It does not work with trigonometry function. That's trigonometric function. It does not work with it. Another one is, it does not distinguish between scalar and vector quantities. So that will be all for today's class. Let us as well subscribe. If you have not yet subscribed to the YouTube channel, do well to subscribe, okay? Thank you very much. Let's meet in our next class. Thank you.